Let's review what we talked about in Lesson 10.3 in class today. We want to make sure that we're all on the same page when it comes to naming arcs. A minor arc is an arc that is less than 180 degrees. And we always name it with two letters. Or points. So when I'm looking at the minor arc that I have here in green, that means that my arc that I'm talking about has to be smaller than a semicircle. So my arc from A to B, the piece of the circle from A to B, right there that I'm kind of making a little bit more thick, I would label with its two end points. And I would write this as arc AB. If I want the degree measure of that arc, I'm going to say the measure of AB. That means degree. When I want the length, then I'm going to ask for the length. And remember, we've talked about that formula, and we'll talk about it more on this video. Major arcs and semicircles, however, need to be named with three letters. Our major arc is greater than 180 degrees. If I just put two end points on here, we'll just call them X and Y. You don't know if I say arc XY, you don't know if I mean this piece of the arc or if I mean this piece of the arc. So if I'm talking about the major arc, the big one, I have to have another point in between the two end points that's guiding my direction to determine what this major arc is. So let's just put a W in there. Now as I look at this, arc XY has to be this little arc because only minor arcs have two letters. So the big arc, the major arc, from X to Y by way of W will have to be named with those letters in the order. I'm going from X to W to Y. So I'm naming my major arc with three letters. The two on the ends are the end points of the arc. And then that W in the middle, that's my direction guide. Okay, so it tells me to go from X, then to W, then to Y. And it's that piece of the circle that I'm talking about. Semicircles are the same way in that they need three letters to be able to let you determine, are they talking about the left side or the right side? So I'm going to put a diameter in here. And let's just call these S and T. So if I say arc ST with just two letters, you don't know if I'm talking about this side of the circle or this side of the circle. So again, I need a direction letter in between. So if I put, let's say, an R in here, then arc SRT is going to be this piece. If I put, let's say, a V in here, then this piece of my circle I would name as SVT. And that would specifically define for the reader which piece of the circle we're talking about. Now true, both of these do equal 180 degrees. But we don't know what else they're going to ask us. We don't know what other exercises they may come up with. And there may be a great variety. So we'll just make sure that we know that to name our arcs for semicircle, we need three letters. for a major arc, we need 3 letters. For a minor arc, we need 2 letters. Today we have a couple of rules, theorems about the relationship of arcs and chords. In this first theorem, Theorem 10.2, it says, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So what that's telling me with the picture I have here in Theorem 2, try to make it a little bit bigger right now, is I've got a biconditional going here. So my if and my then can be interchanged. If I know that this arc is the same length as this arc, then in this same circle or in congruent circles, that means that the arc from F to G is going to be congruent to the arc from J to H. Conversely, if I know that the arcs are congruent, if I know that F, G, and JH are the same shape and size, then I can conclude that my chord measures are the same length. And if you'll think about that with respect to the shape of a circle, I hope that makes sense to you. Now, if you'll look at the example they give us here, we see that they give us circle J and circle K, and by the fact that these are named circle J and K, that tells us for a fact that J and K are the centers of those circles. Now, they tell us that MN is congruent to PQ. Not only do they tell us that over here in the directions, but they've showed it to us in our drawing. If those arcs are congruent, then that means that the lengths of the segments, MN and PQ, have to be the same length. And if they're the same length, then I set the algebraic phrases that stand for their measure equal to each other. Once you work out that problem, make sure you go back and plug in the answer, because they asked for the length of PQ. They didn't ask for the value of X, although we have to find the value of X to get to the answer. Make sure you go back and answer the question that was asked. So in the guided example, the guided practice example here, again, we're told that RS and TV are congruent arcs, so we need to set this up so that their chords are equal. And if their chords are equal, okay, then X is 4 in each one. They ask for RS. So I need to replace my X with the value I found X to be. And we're going to find that RS is 11. Now, if you want to check that, you could plug 4 in here and make sure you also get 11. Because if you didn't get the same number, then quite probably you made a mistake in your either algebra here or in your plugging in. So by double checking, even mentally, in the other problem, is real helpful to you. The second theorem about chords and congruent arcs is Theorem 10.5. In the same circle or in congruent circles, 2 chords are congruent to each other, same shape and size, if and only if they are equidistant from the center. So if here's my center at circle L, and I've got, this is my distance to chord FG. Notice it has to be the perpendicular distance. And then I've got LY here, perpendicular distance. If those 2 measures from the center are the same length, then I know that these 2 chords have to be the same length, and vice versa. If the 2 chords are the same length, then they are the same perpendicular distance from the center of the circle. Let's look at the algebra example. In circle A, WX equals XY equals 22. So WX and XW are the same. They're both 22. Well, if they're both 22, then we know that their distances to the center of the circle are the same. So I know that from A to B and from A to C have to be the same distance. So to solve that, I can just set those two algebraic expressions equal to each other and find out that my x is 2. Again, we are asked for AB, so we have to plug in the 2. And we find that AB is 10. If we double check AC, we get 10 as well, so we feel good that we probably got correct. In guided practice example 5, we're told that our distances to these two chords are the same. They're both 8. So that tells me that my two chords have to be the same length. So I would set the length of PQ equal to the length of RS. And I'm going to find that my X is 6. And in this case, that's all they asked me for. Here we have some examples that are in your book. We can set up a few of these to make you feel a little bit more comfortable before you do your homework. Number 7, since my segment AB and my segment ED are the same, then my arc AB and my arc ED are the same. So 105 equals 5x is how I would set that one up. Number 8, if FG is the same, then HJ is the same. Okay, those two are the same. Then remember that if the arcs are the same, an arc and its central angle have the same measure. So since this arc and this arc are the same, and this arc and its central angle are the same, x would have to be 70 degrees. Okay, over here, I have 360 degrees in my circle. If I subtract 106 degrees, I have 254 degrees to be split evenly between these two pieces. So when I divide by 2, I'm going to get x is 127 degrees. Over here, since these are both 18, these two chords are 18, then my two arcs are the same. So x is 72. I'm going to go ahead and divide this out because I hear someone's voice right now saying, I wonder what that equals. Okay. On 11, if my two arcs are the same, my two chords are the same, so x is going to be 7. This is one of the easiest lessons in this chapter for sure. On number 12, my measures are the same. 85 and 85 are the same, so my chord lengths have to be the same. On 13, I have congruent circles. So if I have congruent chords and congruent circles, then their corresponding arcs are the same. It should be 54. So x is going to be 27. Okay, now look at 14. It's not harder. It's just got a little something different going for it. It's a little half step extra. I don't have congruent arcs given, but I can find congruent arcs, right? If this is 155 degrees, since there's 360 degrees in every circle, then this piece down here has to be 205. And likewise, if over here I have 205, then this arc over here, this measure has to be 155. Now that I see what's equal to what, you see that if this 3x arc or 3x chord has an arc length of 155, then the 7x minus 44 chord must have a measure of 155. So we're going to get x equals 11 here. But we wanted to check those measures because they could have pulled some shenanigans on us and changed that up. So we wanted to make sure we were clear there. And we're done. If you want to look at any of the videos online, remember Mr. Hammy's videos are the ones that I like to use. They go along with, not only does he do a nice job, but they go along with our textbook. And that's it for this lesson.